In this part, we will explain the third case, and it includes the same method of adding data in the second case, where the rainfall data in millimeter per hour in hours taken from the CHRS site are added more than once to the daily rainfall data taken from the global weather data for SWAT website using the rainfall data entry method type gauge. To clarify this, we go to the following path. Where we make a file entitled GSSHA multi 6 hour 150 mm in many days to add rainfall data for 6 hours more than once. Now we open the WMS program and in it we go to the models bar and select 2D grid models. Then we go to GSSHA menu and in it we click on open project. Then we go to the file with the title GSSHA multi 6 hour 150 mm in many days, and in it we choose GSSHA.prg. Then we press open. Then we go to Project Explorer, in which we go to coverages in which the rain gauge layer of rain station should be present. Then we select tool, select feature point over node. Then we make double click on the black point inside the station. Then we click on define. The XY series editor window appears with rainfall data for hours and days, where in the field unit time we enter the date in the first line or the first day at 5 o'clock. In the distribution field we enter the rain value at this hour, which is 0 mm per hour. Then we go to the next line that represents the rain value for the next hour and for the same day, which is 150 mm per hour, and so on for the rain date, for the rain data for the other consecutive hours up to 11 o'clock of the same day. Then we enter the rain data for the second day, then the third day, and so on for the rest of the days until the 7 days, where on the seventh day we enter rainfall data for the consecutive hour from 5 o'clock until 11 o'clock, and thus we add rainfall data for consecutive hours and two waves, the first wave on the first day and the second wave on the seventh day. Then we press OK, then OK. Then we go back to the models bar and select 2D grid model. Then we go to GSSHA menu and in it we click on precipitation and select gauge, then rain gauge. Then we press OK. Then we go back to the GSSHA menu and in it we click on run GSSHA, and since we have already implemented this case, we go directly to the resolution and click on it. Then we press OK. We wait for results to be read. The results are read. The result appears in the Project Explorer, in which we make double click on the outlet hydrograph. Surface runoff hydrograph appears for this case, where the first peak or the first hydrograph represents the first rain wave for the consecutive hours on the first day, and the second hydrograph represents the second wave of the consecutive hours of rain on the seventh day, and between the two peaks no result emerged because the value of rain distributed over the whole day and not over the 1 hour. Then we make double click on the summary file. Then OK, a summary of the results for this case appears. Where by making a comparison between the results of the first case and this case, we find that the value of volume of rainfall to overland flow for first case is roughly half the value of the volume of rainfall to overland flow for this case. As we see, and that is because there is two waves for consecutive hours in 2 days. The value of volume of infiltrated water for the first case is approximately half the value of the volume of infiltrated water for this case. The value of volume of discharge for the first case is approximately half the value of the volume of discharge for this case. That is all the results for the different values in this case have become almost double what they were in the first case due to the presence of two waves for the consecutive hours in 2 days in the first case instead of one wave in the first case, as we see here where the two hydrograph peak appears. Now we close the WMS program, and so we finished explaining the third case. Now at the end of the implementation of GSSHA and WMS, we will make some important notes as follows. First, the file of the project for implementing GSSHA and WMS must be placed inside a partition of the hard disk that contains a large memory size. As we passed in implementing GSSHA and WMS for the study area with an area of 143.19 square kilometers for daily rainfall data for 14.5 years. The implementation took a size of memory 162 GB and the implementation took 6 hours. That is in an average of 20 to 30 GB per hour. whereas it took 2.5 hours to read the results and took a volume of memory in partition C 28 GB, i.e. 1 GB per 5 minutes. And therefore, if we implemented GSSHA in WMS on the total area for Wadi Al-Mur Basin of 2,500 square kilometers, then we need to put the file of the project in the external hard size 1 terabyte, and the implementation may take 24 hours or more, and there must be a memory size in partition C of at least 50 to 100 GB to read the results. Second, the amount of memory taken to read the results of GSSHA in WMS implementation disappears after closing the WMS program and then restart and then opening the WMS program. Third, the map of the shapefile prepared for the soil type and land use must cover 100% of the area of the study area. Otherwise, an error appears in the program and GSSHA in WMS is not implemented. Fourth, the rain data in millimeter per hour must be entered in column Y in hours and consecutive hours within column X for the time and date, so that the rain values in millimeter per hour are distributed over the number of hours, and then the surface runoff hydrograph can appear. Whereas if the rainfall data in millimeter per hour were entered in column Y and the consecutive days within column X, the rainfall data in column Y would be distributed over the whole day, and then a hydrograph might not appear, which means no surface runoff. Thus, we have completed the implementation of GSSHA in WMS with an explanation of all cases and possibilities for implementation.